for accepting wholeheartedly to conduct the 71st International Virtual Learning Series with the blessing of Almighty, our founder Kalvi Vallal Deivathireti Kalasalingam Ayya, and with the support of our chairman Ilay Vallal Dr. S. For this 71st International Virtual Learning Series in association with the Anbu sir, can you hear? Yaru? Hello? Yeah, yeah. Today, I am background teacher and disputed researcher and honorable Professor Dr. Department of Pharmacy, East West University of Bangladesh. It is a great honor to have with the valuable part of this session. It is a great pleasure for all of us that you could find time to be with us despite of your busy schedule. Can you hear, Anbu?
Yes, sir. Yes, sir.
Madam, your prestigious presence.
So we can't get your voice, sir.
Madam, we are fully appreciate. Madam, we appreciate you for finding the time to be with us despite of your busy schedule, madam. Most welcome, madam.
Thank you so much. Can you hear me?
Finally, I welcome all the.
Yeah.
Please. Finally, I welcome the professor and my dear enthusiastic students for today's session. So, dear students, kindly grab and utilize this great opportunity to explore your knowledge. This is the first and foremost needed for your career. All the very best, my dear students. Once again, I welcome you all. Thank you. Most welcome, madam. Please continue your session, madam. Madam.
Okay. Thank you so much.
Continue your session, please. You can proceed.
Okay. Thank you, sir. Good morning, everyone. I would like to thank Professor Dr. N. Venkat Tesan and Professor Dr. S.R. Senthi Kumar. And I'm very glad and I feel privileged that you are invited me for such a kind of prestigious online session. And I will be very glad if my space gives some knowledge helpful for the students also. I'm very glad to participate in the video. So now I'm going to share some of my knowledge which I have done during my PhD period. So here I'm going to start my presentation in front of you. Thank you so much. First of all, I'm going to present molecular mechanism for the onset of non-alcoholic steatohepatitis in diabetic conditions and its treatment strategies. So, cases of fatty liver disease with inflammation that resembles alcoholic steatohepatitis but occurring in non-drinkers were described more than 30 years ago. first in the Japanese literature and then in the United States. Non-alcoholic steatohepatitis, which is termed as NASH, is widely considered to be the liver expression of the metabolic syndrome. The term NASH was coined by Dr. Ludwig and his colleagues in 1980 to describe the biopsy findings in patients with steatohepatitis. NASH can eventually lead to advanced fibrosis, liver cirrhosis, and liver failure. NASH will become an increasingly common liver problem in both rich and poor countries, increasing the global burden of liver disease and affecting public health and healthcare costs globally. It is estimated that non-alcoholic fatty liver disease or NASH will increase 5-year direct and indirect medical costs by 26%. So, let me introduce some terms regarding non-alcoholic steatohepatitis. So, from this, we can see this is the normal liver. In case of non-alcoholic fatty liver disease, the liver weight increased about 5%, more than 5% of the body. And at the same time, generally liver contains some fat, but when the fat accumulation, fats like triglycerides accumulation increase more than 5% of the body weight, then we term that is fatty liver. And if the condition occurs without drinking any alcohol, in that case we can say that is non-alcoholic fatty liver. But when we can say that is disease, along with fat, if there is some inflammation areas, and if the inflammation sustains for a long time without treatment or without recovery, then some fibrosis may occur, and in that condition, the fat with inflammation, we can say that is the non-alcoholic steatohepatitis. And this non-alcoholic steatohepatitis may progress to fibrosis, cirrhosis, and eventually it can progress to hepatocellular carcinoma. So here we can see the progression of NASH. This is the liver disease spectrum. From here we can see this is normal liver. And due to the obesity or diabetes, it can be progressed to fatty liver, or along with the fatty liver, here we can see some cytokines, inflammatory markers or cytokines accumulated there, and it may progress to NASH. And here from NASH to fibrosis and cirrhosis, and eventually it may progress to liver cancer. Due to the NASH, the survival rate is decreasing among the when compared to the general people. And this NASH is responsible for increasing the cardiovascular-related mortality and liver-related mortality. But I want to share something with you. The NASH is in most cases asymptomatic. The people who have the NASH but feel as normal. But they cannot they feel well, they cannot understand they are suffering from liver-related disorders or liver problems. But when it progresses to severe stages like cirrhosis, only that situation, some people can realize that they have some problem. So this is very dangerous issue. So it is called NASH is a silent killer disease. So here we can see the pathophysiology of non-alcoholic steatohepatitis. There might be several reasons for the progression of non-alcoholic steatohepatitis. Some like it may be the overeating or obesity. So due to the overeating or physical inactivity, so excess energy adipose mass may increase and it may cause hypoxia or impaired blood flow, adipocyte cell death increase, and there might be increase the cytokines and chemokines, and it causes the macrophages activation and it causes the non-esterified fatty acid elevation, and the adiponectin may decrease. And for that reason, free fatty acid are increased in the liver, and this causes the triglyceride accumulation. So it may cause from the excess consumption of sugar or excess fatty food. So the novel lipogenesis, triglycerides may increase. So very low density lipoprotein will be increased. For that, there are several markers will be increased, and as a result, the high density cholesterol level decreases. So this may cause the impaired due to the diabetes or type 1 or type 2 diabetes may also responsible for this process also. And this is non-alcoholic fatty liver disease is a burden disease worldwide. If we see in several countries of the world, the rate of non-alcoholic fatty liver disease or NASH is increasing dramatically. And in Japan, 29% of the general people are suffering from non-alcoholic fatty liver disease. Among them, 2% are either NASH or hepatocellular carcinoma patients. In India, if we see, about 32% of the general population are suffering from the non-alcoholic fatty liver disease. And if you see in France or other countries, there are so many, 60% is non-alcoholic fatty liver persons, and among the 60% non-alcoholic fatty liver disease patients, 33% are suffering from NASH. And if we turn to the US, the non-alcoholic fatty liver disease, percentage of non-alcoholic fatty liver disease is increasing. And due to the NASH, the liver transplantation is increasing dramatically. And I want to say that this NASH or non-alcoholic steatohepatitis is not only confined to the liver, it is also causes of the extrahepatic complication of, and so it may cause the colon cancer, along with the hepatocellular carcinoma, chronic kidney disease, diabetes mellitus, and so many other diseases. So what are the risk factors for this non-alcoholic steatohepatitis and hepatocellular carcinoma? Mainly, there are several risk factors, among them diabetes, obesity, and metabolic syndrome. We can say this is also metabolic disorder. When we can say the metabolic syndromes are responsible for this. Among the metabolic syndrome, there are central obesity, high blood pressure, low HDL, high triglyceride, high glucose level, hypertension, sleep apnea. We can see obesity is responsible for the one of the response for the non-alcoholic steatohepatitis and hepatocellular carcinoma. But there are another group of patients who are metabolically obese but normal. Among them, there are some risk factors like dysfunctional fat, decreased muscle mass, genetic factors, different pattern of gut microbiota, genetic changes. So there are several drugs that are under investigation for NASH, like some PPAR agonist or antagonists, and so many drugs. No therapies are approved for the treatment of NASH. So, to prevent disease progression of NASH, physician recommends lifestyle changes, exercise to reduce body weight, treatment of concomitant diabetes and dyslipidemia. All are accepted as the standard of care, but none are conclusively shown to prevent disease progression. American Association for the Study of Liver Diseases guidelines recommends vitamin E for first-line therapy in non-diabetic patients with NASH. So, very few of the patients can recover themselves to the lifestyle change. So, to challenge this problem, the pharmacological therapy is must. present studies were aimed to investigate the effect of type 1 diabetes mellitus on liver and its treatment options. To investigate the relationship between non-alcoholic steatohepatitis and hepatocellular carcinoma under diabetic condition and their mechanism. To investigate the treatment and prevention option of the non-alcoholic steatohepatitis, hepatocellular carcinoma under diabetic background. As we have seen, there are several risk factors responsible for the non-alcoholic steatohepatitis. Here we are focusing on diabetes. Non-alcoholic, but how the diabetes are responsible for the progression of non-alcoholic steatohepatitis and how can we, what might be the treatment for this. So in our experiment, we have performed the studies for the investigation, the effect of various treatments for prevention as well as curcumin on NASH mice model. So why we choose the curcumin for treatment of NASH at first? So what is curcumin? Curcumin is 1,7-base 4-hydroxyl 3-methoxyphenyl 1,6-heptadiene 3,5-dione. And it is a natural polyphenol compound found in the turmeric, which is Curcuma longa plant, and possesses potent antioxidant, anti-inflammatory properties, modulate the activity of protein kinases, membrane ATPases, and transcription factors. So there are several derivatives of the curcumin. For commercial, curcumin contains approximately 77% diperolyl methane, 17% dimethoxycurcumin, and 6% base dimethoxycurcumin. Some data suggest that such a mixture of curcuminoids have synergistically greater activity than any of their individual elements. So there are several studies till today have been done on curcumin. So to date, more than 50 clinical trials have been completed. Most of these trials have suggested that curcumin is safe and effective in a number of human diseases. The most promising effects of curcumin have been observed with cancer, inflammatory conditions, skin, eye, liver, neurological disorders, and pain. So, curcumin participates in several it has the effect in the several markers like transcriptional factors, inflammatory cytokines, enzyme gene expression, receptors, growth factor, and others, so many. Accumulating evidence suggests that curcumin has a diverse range of molecular targets, including complete inhibition of the activity of protein kinase C. Curcumin enhances pancreatic beta cell function by inhibiting phosphodiesterase activity and regulated insulin secretion under glucose-stimulated conditions. Curcumin protects liver injury against tetrachloromethane, aflatoxin B1, alcohol, and paracetamol toxicity. A previous study has been pointed to the protective effect of curcumin on acute liver injury by inhibiting nuclear factor kappa light chain enhancer of activated B cells and oxidative stress. Curcumin protects liver injury by inhibiting endoplasmic reticulomestrase in diabetic rats. So here I have divided my lecture in two parts. One is the effect of curcumin on diabetic liver, and in another part I'm going to discuss the effect of curcumin on the non-alcoholic steatohepatitis liver. So here I'm going to discuss about the curcumin amyloids streptozotocin induced liver damage through modulation of endoplasmic reticulum stress-mediated apoptosis. So we know what is diabetes mellitus. So elevated amount when the blood glucose level is elevated, in that condition we call the diabetes mellitus. So there are three types of diabetes mellitus, mainly type 1, type 2 and gestational diabetes. So we know that type 1 diabetes is about 90% and 5% is type 2 diabetes is about 90% and type 1 5% remaining is the gestational diabetes. So what happens? What is the function of the glucose, or how the normal use of glucose? So here we can see in case of normal cases, there is available concentration of the insulin in the bloodstream as along with the glucose in the glucose enters the bloodstream from the digestive system, and liver and insulin enters the bloodstream from the pancreas. So what's the function of insulin student? The insulin helps to transport this glucose inside the cell. So from that glucose, our cell can get the proper energy. But in case of type 1 diabetes, glucose enters the bloodstream from digestive system and liver, but due to the diabetes or due to the damage of the pancreas, there is no insulin available to bind with the cell. So glucose cannot enter into the cell. As a result, cell has no effect for no glucose for fuel. So in that case, glucose returns to the bloodstream and our cell suffer from the deficiency of proper energy. So there are several signs, symptoms, and complications of diabetes mellitus, like polyuria, polydipsia, polyphagia, and several complications like cardiovascular complication, renal complication, retina complication, neuro complication, and hepatic complication. And in case of what happens in case of diabetes for the liver, liver as the major target organ of insulin and plays important roles in the development of insulin resistance and diabetes mellitus. Studies have shown that hepatobiliary disorders such as the inflammation and necrosis or fibrosis of non-alcoholic fatty liver disease can follow diabetes. The liver plays a central role in regulating nutrient and lipid metabolism. Hepatic fat accumulation and oxidative stress play a critical role in the development of diabetic liver injury. It has been reported that the standardized mortality rate from end-stage liver disease, that is cirrhosis, in diabetic patients is higher than those with cardiovascular disease. So there are clinical and structural changes of diabetic hepatopathy. In case of biochemical markers, there is progressive increase in the plasma glucose level, decline in glutathione peroxidase level, and increase in advanced glycation end products in liver. It is causes of increasing of total cholesterol, triglycerides, ALT levels in the plasma. And if you see the histological change, the hepatomegaly, microvascular, vascularization, focal necrosis, inflammation, sinusoidal fibrosis in liver, parenchymal cell is found. What is the endoplasmic reticulum? Endoplasmic reticulum plays essential roles in intracellular calcium homeostasis, protein folding, protein secretion, and lipid biosynthesis. Multiple disturbances that reduces the protein folding capacity of endoplasmic reticulum will result in the accumulation of unfolded protein inside the endoplasmic reticulum mesentery, which termed as endoplasmic reticulum stress. So, What's the relationship between the endoplasmic reticulum stress and liver disease? Since hepatocytes have a well-developed endoplasmic reticulum structure, so ER stress is involved in liver-related disease. It is reported that disruption of endoplasmic reticulum homeostasis has been observed in liver and adipose tissue of humans with non-alcoholic fatty liver disease. Perturbation of ER homeostasis contributes to hepatic steatosis, inflammation, and insulin resistance in liver. Importantly, the signaling pathway activated by disruption of endoplasmic reticulum homeostasis, the unfolded protein response, has been linked to lipid and membrane biosynthesis, insulin action, inflammation, and apoptosis. Although many aspects of curcumin induced by cytoprotections are studied, the molecular mechanism by which curcumin protects liver tissues against streptozotocin-induced liver injury is not clear. So here, the study was designed to shed light on this issue. In the light of the important role of the liver in glucose homeostasis and the pathogenesis of diabetes, we should examine the potential effect of curcumin on the ER stress response signal in hepatocytes of diabetes animals. So how we did the experiment? For the experimental protocol, we chose fragile rats, which are 8 weeks of age and weighing from 250 to 280 grams. And we chose the male rats, and the rats were injected with streptozotocin, so intraperitoneally with a dose of 55 milligram per kg of body weight. And after 48 hours, we checked the blood glucose level. When the blood glucose level comes more than 300 milligram per deciliter, in that case, we consider that is a diabetic rat. So there are 3 groups. Normal group are age mass non-diabetic control. Group DM, diabetic rats, which are injected with this streptozotocin. And another group was DM plus curcumin. The diabetic rats treated with curcumin at a dose of 100 milligram per kg of body weight. We started the curcumin treatment after the induction of diabetes, or after the 3 weeks of the induction of the diabetes. And we continue the treatment for 8 weeks. And after 11 weeks from the injection of the streptozotocin, we sacrificed all the elements. So for the analysis, we checked the normal body weight, liver weight, and the liver to body weight ratio, and we checked some parameters in the blood. And through the Western blot analysis, we checked several markers related ER stress, UPR activation markers, ER stress associated apoptotic markers, anti-apoptotic markers, inflammatory markers. And for the histopathology analysis, we use hematocin and Asian staining. At the same time, we use periodic acid escape, that is fast staining. So what is our findings? First of all, the effect of curcumin on biochemical parameters. From the table, we found that in case of DM group, all the parameters are significantly increased when compared to the normal group, like liver weight, plasma glucose level, triglyceride, total cholesterol, LG, urine volume, and proteinuria. What happens in case of treatment group? We found all the parameters are significantly reduced in curcumin treated GM group. So here I am showing the time course changes in blood glucose level. So after treating with the curcumin, we found that after 6 weeks of during our experiment, the blood glucose level is gradually decreasing with the curcumin treatment. The effect of curcumin against hepatic histological changes. So this is the fast staining, periodic acid escape staining, and in here we use the hematoxylin and insulin. From the fast staining, we can see the intensity of this color is decreased in the DM group. So what does that mean? The decreasing of intensity of color by this pink color indicated that the accumulation of glycogen is decreased in the liver. On the other hand, if we observe the treatment group, the intensity is increasing. So if we compare with the disease group and treatment group, we can find some improvements of the liver in the treatment group. At the same time, if we see the HE staining tissue section, here we can see this is the normal liver tissue section, and this one is the diabetic mellitus liver. So here we can find that the enlargement of the cell, and there are some necrosis of the liver, and on the other hand, there is improvement of the curcumin treated group. The effect of the curcumin on ER stress marker. So we know that GRP78 is the main marker of the ER stress, and here we can see the elevated concentration of the GRP78 in the GM group. But on the other hand, curcumin treatment significantly reduces elevated concentration of the GRP78. The effect of curcumin on stimulation and regulation of unfolded protein response in the diabetic liver. So all the UPR marker proteins are significantly elevated in the diabetes group. On the other hand, curcumin treatment significantly reduces all these groups. The effect of curcumin on ER stress-induced apoptosis. When ER stresses occurs, that may causes of the apoptosis. So here we check some apoptotic marker like CHO. This apoptotic marker CHO just 2 as for 1 phosphorylation of P38 and PK increased significantly in the DM group. On the other hand, curcumin treatment significantly reduced all these markers. So effect of curcumin on apoptosis. In the case, we have checked that some caspase level also in the liver. So here we found the caspase level, cleaved caspase flows increase, but not insignificant in DM group. And in curcumin, it tended to decrease, but cleaved caspase share significantly increase in DM group, and curcumin significantly able to reduce that elevated level. On the other hand, anti-apoptotic marker BCL2 significantly reduced in the DM group, but curcumin treatment significantly increased. Then we checked some inflammatory markers in the liver. We found that tumor necrosis factor, interleukin 1 beta, TLR4, all these parameters significantly increase in DM group, but curcumin able to reduce all those things significantly. So, our findings from this experiment show that curcumin protects against the development of diabetic hepatopathy. The findings of this study also suggest that stress-related inflammation and apoptosis are involved in the pathogenesis of various diseases, including hepatopathy, and curcumin inhibits stress-related apoptosis and inflammation in the liver of streptozotocin-induced diabetic rats. Winter's extremely good safety profile and long history of safe use, curcumin may find clinical application in preventing complication in diabetic patients. So our findings here, at a glance, we can say, in case of normal stage, in endoplasmic reticulum, this GRP78, IRE1 alpha, ATF6, and PARC stages are in a complex form. But due to the type 1 diabetes, the hyperglycemia and advanced glycation in products is elevated, and this may cause some endoplasmic reticulum malfunction. As a result, it causes induction of the ER stress, and we found that elevated level of the GRP78. So, in case of ER stress or ER endoplasmic malfunction, what happens? The dissociation of these proteins is occurred. So we found in case of ER stress the elevated amount of the GRP78, and as a result, there is the elevation of this unfolded protein response protein, like there is increase the PIRA, phospho-IRA1 alpha, phosphopart, and activation of the several cascade pathways. This PIRA1 alpha is responsible for the recognition of the TRAP2 pathway, and it may increase the AST1, and at the same time, napkinase protein like phosphorylation of the P38 napkinase. And when the PARC is activated, it may causes the apoptosis, so the elevation of the tumor. And in terms of activation of caspase pathway, we found that elevated caspase 3 and caspase 12. So as a result, for the elevation of those of these proteins, hepatic apoptosis is aroused. And at the same time, the anti-apoptotic marker protein BCL2 is decreased, and due to the recruitment of TAP2, the activation of inflammation is occurred. We found that through the checking of some cytokine, like TNF-alpha, IL-1 beta, TLR4, and as a result, cell death may occur. And due to this reasons, due to this reasons, what happens? Diabetic hepatopathy is found, and this may occur from the metabolic dysfunction also. But ultimately, it may cause liver damage. On the other hand, our curcumin treatment protected all those things by reducing the elevation of this, by altering all these pathways. So now, the findings from these things inspired us to move forward. So as the curcumin is able to reduce the diabetic-induced hepatopathy, what happens in the progressive form of the liver disease like non-alcoholic steatohepatitis or hepatocellular carcinoma? I want to share the things this work has been published in the periodical research journal. So in the second part, I want to disclose that curcumin ameliorates liver damage and progression of non-alcoholic steatohepatitis in non-alcoholic steatohepatitis hepatocellular carcinoma model, possibly by modulating HMGB1 in a kappa beta activation process. So, why I choose NASH-HCC model? Why we choose this model? We know for the invention of any drug, the animal model or any model is very much important. So in our model, we found that the progression of the disease stage of the non-alcoholic fatty liver disease very much similar with the human fatty liver disease. So we choose this model and to be prepared this model. NASH is considered as a hepatic manifestation of the metabolic disorder and exceedingly connected with diabetes and may progress to HCC. Inflammation promotes the progression of NASH and has also been a critical factor in the progression of HCC. High mobility group works like HMGB1, which is a DNA binding nuclear protein, is a leaderless pro-inflammatory cytokine and is an important member of inflammatory cascade. The role of HMGB1 as a damage-associated molecular pattern has led to its implication in a variety of disease states, mediated by inflammatory stimuli, including sepsis, arthritis, liver ischemia perfusion, injury, liver transplantation, cancer, hepatocellular carcinoma, and apoptotic dermatitis. Extracellular HMGB1 can activate NF-kappa and its inflammatory signaling through binding to different cell surface receptors, including TLR2 and TLR4. So if we see the pathogenesis of NASH-HCC, what happens? First of all, in case of non-alcoholic fatty liver disease, that is represented as steatosis. That means fat is appeared there. So it increases the toxic lipids in the liver tissue, and it may progress to inflammation. And this increased toxic lipids may also responsible for the oxidative stress, pro-inflammatory chemokines, and cytokine celebration. So these all are responsible for the inflammation. And progressive inflammation are responsible for the hepatocellular injury, and it may progress to NASH. And these NASH may progress to either fibrosis or liver cirrhosis, and this prolonged fibrosis and liver cirrhosis turn into the hepatocellular carcinoma. Now, what is the role of 18GB1 in this pathogenesis? Can you hear me properly? Okay, thank you. Regulation of 18GB1 during tissue damage. What happens? During the tissue damage, the HMGB1 might be activated directly or indirectly. That activated HMGB1 bind with the surface protein like surface protein receptors like TLR2, TLR4, and ratio. Right. So these are response when they bind with the surface receptors and they enter into the cell and they activate the NF-kappa. So NF-kappa activation release of additional pro-inflammatory mediators like TNF-alpha, IL-8, MCP, and so many cytokines. And these cytokines, again, they are responsible for the activation of the macrophages and activation of the NF-kappa. So this is a cycle process, and the activation of the NF-kappa, it also again may responsible for the activation of the HMGB1. So we can say HMGB1 may be activated directly or indirectly. And this activation of the NF-kappa or prolonged activation of the NF-kappa may be responsible for the tissue damage. The data of the previous study inspired to investigate the underlying mechanism of curcumin to protect liver damage and progression of NASH in a novel NASH-HCC mouse model. In our experiments, we have used 357 female mice. That mice were we treated that mice in our laboratory, and that was we took the pregnant female mice, and after the birth of the pups, we used to inject that baby mice subcutaneously with a dose of 200 microgram per month for inducing the type 1 diabetes, we can say here. So, after injecting the stages, from the injection of the stages, after 4 weeks, we are used to provide high-fat diet to that mice. And for our experiment, we choose only the male mice here. And we continue that providing a high-fat diet from the 4 weeks of the age to the 14 weeks of the age. So, and in the treatment group, we used the curcumin at the same dose, 100 milligram per kg, using oral cases from the age of 10 weeks to 14 weeks. That means we provided the treatment for NASH mice only for 1 month. And after the 14 weeks of the age of the mice, we sacrificed all the mice for further experiment. So for the analysis, we generally took during the experimental period, we took the food intake, body weight, and after the sacrifice, we measured the liver weight, and so from the blood, we check the blood glucose level and aminotransferase level, and ALT level, alkaline phosphatase level, Kz and Kc. For the purpose of the histopathological test, we used HA staining, and from the HA staining, we calculated the NAFLD activity score. And using the messenger chrome staining, we calculated fibrotic score. So, for the calculation of the NAFLD activity score, that is NAS, we used the HA staining, and from here we can see some things like from the image, you can see this circle, and this represent the inflammatory cells, and this dotted line, it indicates the macrovascular steatosis, and this is very small white spot, and inside you can see some spot is there, nucleated fat. This is so it is a microvesicular steatosis, and this bold arrow indicates the hypertrophy. That means enlargement of the cell. So there is the percentage of the scoring. So from there we can see that if the NASH score, when we can see that mice or tissue is affected with the NASH, if the number is more than 5 or equal of 5, we can say that is the NASH affected. But if the NASH score is 3 or 4, that is the borderline NASH, and if less than 3, there is no NASH. So this score is among 12. Now, for the fibrosis score, we use that empty staining, and from this blue color is indicating the fibrosis. And using Western blot technique, we analyze some protein, and we check some protein for the fibrotic marker like connective tissue growth factor. For the inflammatory marker, we chose HMGB1 TLR4, interferon gamma IP10, IL-1 beta, CD68, and kappa B, I kappa B alpha, oxidized low density lipoprotein receptors, and we check the lipogenesis marker, some oxidative stress marker, some antioxidative marker, and for the HCC marker, we used vascular endothelial growth factor, glypican-3, and just gamma carboxy prothrombin. And let's see the findings. Changes in the biochemical parameters after 4 weeks of treatment with curcumin in NASH-HCC mice. Here we find that except the body weight, all the parameters like relative liver weight, blood glucose level, AST, LDL, PTs, and TC levels are significantly elevated in the disease group, that is NASH group, compared to the normal group. But on the other hand, in case of curcumin treated group, we found that all the parameters are significantly reduced. So, what is the effect of the curcumin on liver steatohepatitis? So, if we see the figure of the liver here, what happens? This is the macroscopic appearance of the liver. This is normal liver, and this is NASH liver. From this NASH liver, from visually, in the naked eye, we can see that there are some appearance of the tumor here, and the color of the liver skin. So here we can see some scar tissue also we can see from the naked eye. On the other hand, in case of curcumin treated group, we did not find any tumor protrusion. There, if we compare with this treatment group with the normal group, we can say this is quite some fatty liver, but no tumor protrusion or no scar tissue was found in that case. From the HA staining, we found that in case of disease group, there is the accumulation of macrophages or inflammatory markers, inflammatory tissues, and some are white places. You know that using the HA staining, the fat tissues cannot stain, so these white colors are fat indicating. So in case of NASH, we found that the very much fat, which of the macrovascular and microvascular fluids, and the enlargement of the tissue. And in case of treatment group, there is improvement of the liver. So from the HA staining, we have calculated the non-alcoholic fatty liver disease activity score, and in case of NASH group, it was found around 8. On the other hand, in case of treatment group, it is around 4. So we can see the improvement of the liver with the curcumin treatment. At the same time, in case of staining with the mesenchyme, we have found that the fibrotic percentage of the fibrotic area is increased in the disease group, and on the other hand, it is trying to decrease in the treatment group. Effect of curcumin on the some fibrosis marker like the CTCF is elevated in the disease group, and in treatment group, the concentration of the CTGF protein is significantly reduced. The effect of curcumin on inflammatory markers. Here we can see we have checked the HMG-B1 protein both in the cytosol and the nucleus of the hepatic tissue. So we have found that the ratio of the both in the here we found that the HMGB1 in the NASH group when compared to the treatment group. So here it indicated that the translocation of the HMGB1 from the nucleus to cytosol is increased in NASH group, whereas it is decreased in the treatment group. At the same time, we have checked the toll-like receptor 4, and here we found that the increased level of the NASH, increased level of the TLR4, IP10, interferon gamma, iron, interleukin 1 beta, CD68 in the NASH group, but on the other hand, treatment group significantly reduce all this elevation. And the effect of other inflammatory markers, like what happens in case of NF-kappa B expression. So we checked in here also, both in nucleus and cytosol. So, and here we found that this represents the ratio of the protein expression of phospho-NF-kappa B in nucleus and cytosol. So here we found the translocation of phospho-NF-kappa B from the cytosol to nucleus. And at the same time, the alpha B alpha is reduced significantly in NASH group, and it is significantly increased in the treated group. So, curcumin suppresses the activation of NF-kappa B pathway. Effect of curcumin on lipogenesis marker. We have checked some lipogenesis marker. You know that SRBP1C pathway is responsible for the lipogenesis, and we checked the ADRP and PPR gamma. All these markers are significantly elevated in NASH group, but curcumin group significantly reduced all this elevation. On the other hand, in case of PPR alpha, which is responsible for the oxidation of fatty acid, we found that tended to reduction of that PPR alpha in the NAS group, but not in a significant level, and at the same time it is elevated in the treated group. So curcumin reduced the lipogenesis in liver. Checked at the same time some oxidative markers, oxidative stress markers in the NAS liver. So we found that the CHOP or CEBP beta are significantly elevated in NAS group, and cytochrome P to E1 is significantly increased. Phospho-ERK1, 2, P67, all those things are all the oxidative stress marker protons are significantly elevated in the NAS group, whereas curcumin treatment significantly reduces these things. On the other hand, antioxidative marker in our F2 significantly reduced in NAS group, and curcumin treatment significantly increased that in our F2. And the effect of curcumin on tumorigenesis markers, so we found that VEGF, glypican C, and GCP proteins are significantly elevated in the NAS group. As we have seen in the macroscopic liver, there were some tumor protrusion, and these proteins reveal that prove that there might be progression of the hepatocellular carcinoma in the NAS group. And so what happens in our treatment group, curcumin is able to reduce that elevation of VEGF, glypican 3, DCP protein level in a significant way. So the effect of curcumin on NASH-HCC at a glance, you can see that due to the streptozotocin injection and hyperdiet, there might be hyperglycemia, and this hyperglycemia may progress to reactive oxygen species, oxidative or elevation of the oxidative stress, and this oxidative stress may responsible for the elevation of HMGB1 translocation, and when the HMGB1 translocation occurs, there increase the TLR4 protein, and due to the activation or due to the increase of the TLR4 protein, it may responsible for increasing the phosphoenap kappa B translocation, and which may increase the pro-inflammatory cytokines, and if the increasing pro-inflammatory cytokines is responsible for the inflammation, and progressive inflammation may responsible for fibrosis, and if it is continued, it may responsible for the tumorigenesis, and it may progress to hepatocellular carcinoma. And so what happens in case of curcumin treatment, all these are altered, and may prevent or stop the progression of the hepatocellular carcinoma. So this this work has been published in the International Immunopharmacology Journal. So what is the findings? At a glance, we say that this NASH-HCC mouse model shows that resembles with human disease, and NASH progressed to HCC under diabetic condition. Curcumin treatment may protect the liver against the progression of non-alcoholic steatosis to hepatocellular carcinoma in this NASH-HCC model. The findings of this study also suggest that curcumin treatment reduced the cytosolic and nuclear translocation of HMGB1 and NF-kappa. And its related inflammation also reduced the oxidative stress, lipogenesis, and tumorigenesis in the liver of NASH-HCC mice. For the safety profile and hepatoprotective effect in diabetes or other toxic conditions, curcumin may provide a novel therapeutic strategy for NASH-HCC liver. So I would like to thank our affiliated university, West University, and I would like to thank our Migo Kalasingam College of Pharmacy, and at the last but not the least, I would like to thank all the person and my professor Kenchu Watanabe and the Niigata University of Pharmacy and Applied Life Science. Thank you for your kind attention. Please, if you have any questions, please feel free to ask me. Thank you. You're welcome. Can you hear me? Yeah. Thank you.
Thank you, madam. Thank you for your presentation. Any questions? Any questions? Good morning, madam.
Good morning.
Yeah, Southeast Asia. South Asia is one of the hub for the hepatic diseases due to alcohol consumption or lifestyle modification. So you have told about curcumin and its uses for liver cirrhosis and steatohepatitis. So I have a question on that, madam.
Yes, please.
Yeah. So that side effect of curcumin is bleeding, madam. They will induce bleeding and they will thinning the blood. So when we are coming to the case of liver cirrhosis or acute steatohepatitis, uh, there may be chance of bleeding during the treatment period when you are using curcumin, madam. How we can overcome that, madam?
In that case, generally we have done this experiment on the animal model. I have told that thing, and before doing that experiment, we did another experiment in diabetes mellitus, and we checked at the same time. We provided the curcumin at that dose, like same dose, 100 milligram per kg for body weight, which is resemble with the human dose, like 6 gram for 60 kg. But in our experiment, we did not find any complication during our experiment. So, as if we go for the clinical trial with the curcumin, I think in that case we may use the concomitant therapy, or we can use addition other treatments along with the curcumin to overcome that problem. But when we did our experiment, we checked some in case of normal mice also for the toxicity, checking the toxicity level of the curcumin, but we did not find like that problem. So if we found that this problem, I think we should use concomitant therapy, or along with curcumin we may provide the anticoagulants also, or any other pharmacological therapy.
Thank you, madam. So there is a question from the participant. I think Ms. Bhanu Rajendran. This steatohepatitis is responded for. It is due to any gut-related diseases, madam.
Yeah, there are several factors for the steatohepatitis. So it might be that the bladder problem. It might be a cause, one of the cause for the steatohepatitis. We can say the microbiota is also responsible for the that microbiota problem, that is also responsible for the steatohepatitis. Yeah, that might be a problem.
Yeah, thank you. And curcumin having blood sugar lowering activity, madam. So when a normal diabetic person is using curcumin along with his diabetic medicines, if any chance of contraindication or any adverse drug actions, madam, or there may be chance of hypoglycemia.
I think it will depending upon the dose for the chances of the hypoglycemia. and which kinds of anti-hyperglycemic drugs are using that patients. It will depend upon the dose. So we see that curcumin reducing the blood glucose level, but it is not come to the just normal level, but it is significantly reducing. So in my personal opinion, it will depend upon the dose, and it will depend which drugs are using. So we need to check the contraindication between curcumin and which anti-diabetic drugs are using. Like this. Here, the blood glucose level is reducing, but not at the normal level. So it will depend on the two things. In my personal opinion, one is the which drugs is which anti-diabetic drugs are taking at the same time, and what is the patient condition, what is the blood glucose or what is the severity level of the patient. So upon that, it may show either hypoglycemic effect or it no effect, no problem. Like
Madam, curcumin is one of the poorly bioavailable drug when it was taken
yeah,
through orally.
yeah, yeah.
During your studies, have you used raw curcumin as it is, or you have used any modified curcumin, madam?
For our experiment, we have used the purchased curcumin. We did not synthesize the curcumin. We took this one from the sigma address, I saw this is a mixture of different derivatives of the curcumin. Okay, and the viability of curcumin is very less. So in that case, there are several further studies is going on in the world, that is nanoparticle curcumin treatment or so other modified form of the curcumin to increase the viability of the curcumin. This is the limitation of the curcumin. Although the curcumin has a very beneficial effect for the several diseases, but this is the one more limitation for the curcumin, that it has less bioavailability. So by changing the dose modification, by modifying the dose or particle size, so we can enhance the bioavailability as it has many pharmacological activities. But I did not use the nanoparticles or other things. We use only the purchased curcumin.
Thank you, madam. So, if we take curcumin in normally in India or in southern part of India, we are regularly taking curcumin in our meals. But if you see statistics for last few years, there are a lot of fatty liver diseases, hepatic cirrhosis, hepatic injury like that. We are seeing a lot of diseases. So even though we are taking the curcumin regularly in our regular food, what may be the reason behind that liver diseases, madam?
Okay.
What may be the urgent?
Yeah, thank you so much, sir, for your question. We are not exactly taking the curcumin in our regular food. Along with your example, we can say in Bangladesh also, we are taking regularly turmeric. We are taking the turmeric, and the percentage of the curcumin inside the turmeric is very low. So one might be the reason that what we are consuming, the percentage of curcumin is very low, or it is not reaching the minimum effective dose. One thing, and another thing, the reason behind the increasing the stage of hepatitis or fatty liver disease in South India or Bangladesh also, our lifestyle. We are not following the proper lifestyle for due to our heavy work. Due to the less physical activity, it might be um, one of the cause, or diabetes is as a proportion, the prevalence or proportion of the stage of hepatitis is increasing along with the proportion of the diabetes also. So as diabetes or metabolic disorder or metabolic syndromes is very major risk factor for the steatohepatitis. So in that sense, that might be the cause of increasing the steatohepatitis. And another thing, as I told in my speech, non-alcoholic steatohepatitis during this disease or when we are suffering from the steatosis, we cannot realize that something is occurring inside our liver, some problem is occurring because we feel as like as normal. But when we feel the problem, when the problem, we feel some symptoms or we feel discomfort, when the disease progression stage is raised up to serious, when there is no option, like main option is the transplantation of the liver. So in between, we can recover that problem without pharmacological therapy also if we can realize that in case of stage after stage 1, like only the fatty liver, or stage 2, initially if we can realize, and if in that case if we can modify our lifestyle, that is possible to recover. But as we cannot understand the symptoms, so it's a disease progressing in its own way, and that's why the problem is arisen. So I think the main problem is the lifestyle, and along with there are some genetic problems responsible for this steatosis.
Thank you, madam. As it seems, your doctoral research, I think you may when done an extensive research in the area of NASH. So, based on your research, there is any possibilities of pharmacologist therapy for this NASH, madam, or any drugs which can prevent a drug which can extend the life of the NASH patients? So, your opinion on that?
Okay, thank you, sir, for your nice question. From our study and from the several literature review, we found, as we say, there are several um, mechanisms are responsible for the progression of NAS, and for during the NAS, along with we have seen that several metabolic syndrome or disorder uh, elevation of the blood pressure, so other complications, so or elevation of the fat in the liver. So generally, doctors are suggested to doctor prescribes to reduce the symptoms accordingly to the symptoms. But if we say for the if you say the treatment for the NAS only, still there is no acute drug for the NAS. So only the vitamin E, and vitamin E is the responsible for the antioxidative stress. And if we use the vitamin E, it is not work in case of diabetic patient. It will improve the oxidative stress pathway. But here, if we prolong the vitamin E treatment, there are several problems may arise. But still, if we see the study of the several work, there are some several studies like someone is some things are under the clinical trial like PPR agonist or what's that? ASA1 apoptosis kinase marker antagonist are under the clinical trial, but that are all are different drugs are targeting different molecules like PPR agonist, PPR alpha agonist, or AXO1 antagonist, like this. So we cannot say still now there is a particular drug which might be stop the or which might be able to completely cure the NAS. Still now there is no drug in our hands. So it is very much important to focus on the investigation of pharmacological therapy for the NAS.
Thank you, madam. Any other questions?
Thank you, madam. Professor Dr. Afrin.
Thank you, sir.
Dr. Afrin?
Yes, sir. I can hear you. Thank you so much.
Really, we had a informative and wonderful presentation, Dr. Afrin.
Thank you so much.
I hope this interaction will motivate the students and encourage them in active learning in forthcoming days, Afrin. On behalf of our management of AKCP, hereby I express my wholehearted thanks to you and your esteemed university for giving such an informative and wonderful presentation.